This screencast will cover one-way ANOVAs. Suppose you are given the task of examining sit and reach test scores in a sample of males from 3 different age groups, 20 to 29 years, 30 to 39 years, and 40 to 49 years. The purpose is to examine whether flexibility declines with age. Are the differences in mean scores of the 3 age groups statistically significant? Because you have one dependent variable and one independent variable with 3 levels, you would run a one-way ANOVA. The rest of this tutorial will take you through the steps on examining if you are meeting your assumptions and how to then run and understand the results of a one-way ANOVA. Before running the test, we must make sure that all of our data meets our assumptions. The first assumption when running a one-way ANOVA is that the independent variable should be measured with a nominal or an ordinal scale. A nominal scale is when there are distinct groups, for example, control versus treatment 1 versus treatment 2. An ordinal scale is artificially created groups, such as we have here, where we group people into 3 distinct groups based on cluster of ages. Since we have met the first assumption, we can move on to the second assumption. The second assumption is that the dependent variable should be measured with an interval or ratio scale. In this instance, our dependent variable, flexibility, is measured with a ratio scale, so we are safe to move on to the third assumption. The third assumption examines whether the dependent variable, in this case flexibility scores, are normally distributed across the levels of the independent variable, in this case the 3 age groups. We will examine this assumption when looking at the output of the one-way ANOVA. We are now going to draw our attention to SPSS, where we will learn how to run the one-way ANOVA. You are currently looking at data view, and as you can see, both your dependent variable, flexibility, which is highlighted, and your independent variable, age group, are present on the screen. The values in age group are represented by the numbers 1, 2, or 3. This represents each of the groups you have in your study. To see your values defined, switch over to the Variable View page and then click on Values across from Age Group. This will open up a new box called Value Labels. In this box, you can see that 20 to 29-year-olds have been given the value of 1, 30 to 39-year-olds have been given the value of 2, and 40 to 49-year-olds have been given the value of 3. To close this box, simply click OK. We are now going to go through the steps to conduct the analysis. Click Analyze. Click General Linear Model. Click Univariate. This will now open up a new window labeled Univariate. Click Flexibility and then click the arrow to the left of Dependent Variable. Click Age Group and then click the arrow to the left of Fixed Factors. Click Plots. This will now open up a new window labeled Univariate Profile Plots. In this window, you will be able to tell SPSS to create plots displaying your data. Select Age Group and click the arrow to the left of Horizontal Axis. Click Add. Click Continue. Click Post Hoc. This will open up a new window called Univariate Post Hoc Multiple Comparisons for Observed Means. Select Age Group in the Factors column and click the arrow between Factors and Post Hoc Tests for. There are a wide variety of post hoc tests which you can choose from. Some are more conservative and others are less conservative in terms of protecting against type 1 error. For the purpose of this screencast, we will choose the Tukey test. Click Tukey test. Click Continue. Click Options. Under the heading Display, click Descriptive statistics, estimates of effect size, observed power, and homogeneity tests. Click Continue. Click OK. SPSS has now opened a new window labeled Output, which will give you all of the information you need for your results. If you draw your attention to the highlighted box labeled Descriptive Statistics, you can see the means and standard deviations for each of the groups separately and the number of people in each group. You can also see the mean, standard deviation, and total number of participants in the study. The current area highlighted refers to the Levene's test for equality of variances. We discussed this earlier in the video, and this is the third assumption of a one-way ANOVA which needs to be met. To refresh your memory, this test examines whether the variance of the dependent variable is equal across all levels of the independent variable. If the Levene's test is not significant, then equal variances should be assumed. However, if the Levene's test is significant, the assumption of equal variances is not tenable. In this instance, as you can see in the box highlighted in red, the Levene's test is not significant, so we can assume equal variances and move forward with our analyses. The current box highlighted represents the test of between subject effects. This box lets us know if the F value is significant and will let us know if our results are significant, which means it will let us know if there is a significant difference between age groups in flexibility scores. If we look at the box that is highlighted in red, we can see that the F value is 19.211, located across from age group, and that the significance is 0.000. This means that the p-value is less than 0.001. Since the p-value is less than 0.05, we can assume that there are significant differences between groups in flexibility scores. Partial eta squared, which is in the box highlighted in red, is a measure of effect, and observed power is a measure of the statistical power of our design. However, statisticians recommend that power is calculated before and not after a study is carried out. The next area highlighted, labeled Multiple Comparisons, refers to the post hoc analyses. These compare each mean against all other means individually. In this instance, you can tell if the means are significantly different by looking at the significant column highlighted in red. If we start by looking at 40 to 49-year-olds, we can see that 40 to 49-year-olds are statistically different from 20 to 29-year-olds and 30 to 39-year-olds. In both instances, p equals less than 0.001. However, if we look at 20 to 29-year-olds compared with 30 to 39-year-olds, we see that p is equal to 0.685. Therefore, there is no significant difference between these groups. The box currently highlighted in red shows the 95% confidence intervals. If we were to draw randomly 100 samples from the same population, in 95 of these 100 samples, the value would be somewhere between the values reported in the lower and upper bound boxes. The plot is located at the bottom of the output file. As you can see here, each of the age groups are displayed on the horizontal axis, and the flexibility scores are displayed on the y-axis. As we can see, the 40 to 49-year-olds look as if they have a big difference from the 20 to 29-year-olds and the 30 to 39-year-olds. The only reason we know that this difference is statistically significant is because of the results of the post hoc analysis. This slide goes over how to report the results. There were significant differences between groups in flexibility. Post hoc analysis revealed that 40 to 49-year-olds were significantly less flexible than 20 to 29-year-olds and 30 to 39-year-olds. When reporting the results of a one-way ANOVA test in text, you should report the F value, its degrees of freedom, and the probability value. The degrees of freedom are reported in brackets. In this case, they are 2, 27. The values 2 and 27 represent the between and within group degrees of freedom and are available in the output under the table entitled Test of Between Subjects Effects. The between group degrees of freedom are given in the row which has the name of the independent variable, in this instance age group. The within group degrees of freedom are given in the row entitled Error. It is also important to report which group means differed significantly from the rest by presenting the result of a post hoc test. The results could also be reported in table format, as is indicated below. In this format, you have each of the three groups listed separately, with their mean score for flexibility listed below them. You also report the F statistic and the degrees of freedom. In this screencast, we have gone over the assumptions assumed when analyzing a one-way ANOVA, the steps of how to analyze a one-way ANOVA, and how to read the output and report the results of a one-way ANOVA.